Hello everyone, Gaza Mutkarsh, and I welcome you all to the session on data cleaning and pre-processing. So guys, let's have a look at the agenda for this session. The agenda for this session includes data scaling approaches in pandas. Essentially, we'll be focusing on standardization and normalization. We are going to understand its concept and we'll be proceeding with its implementation in pandas. So guys, till the previous session, we have implemented type conversion. We have implemented how to handle missing values, how to handle duplicates. So guys, let's switch to the Jupyter screen. So guys, over here we are in the Jupyter screen. All right. So guys, let's understand what do we mean by data scaling. So data scaling, let's say, essentially means, let's say, scaling the data or pushing the boundaries of the data in terms of its minimum and maximum value in terms of each and every data point, all right, is pushed to a certain limit. The same process can be implemented using standardization and normalization. Now, the very question that comes to the mind is, why do we need data scaling in the first place? Or why do we need to, let's say, what are the scenarios into which data scaling is required? So let's understand the concept. Standardization and normalization are the two common techniques used in data pre-processing to scale the numerical features. All right. Now, though often used interchangeably, they are conceptually different and serve different purposes. So let's consider an example. Suppose we have a data. I'll be creating this data as well. We have a data over here where we have the employee name, we have employee age, then we have salary, then we have maybe experience. All right, experience is in years, salary is in thousands, age is in let's say number. Then besides this, we have city. All right, these are the columns that we have. So let's create this columns first. So over here I'm importing pandas as PD. All right, I'll be importing numpy as well. Over here, as you can see, I've imported numpy and pandas, right? So once we have imported this numpy and pandas, then what can be done? Let's say I want to create a data where I'm having these columns. Maybe I can pass the employee ID as well. So how do I create the employee ID? This is employee ID. Employee ID would be, let's say, list, range, and then maybe ranging from 100 to 1, maybe 130. All right, let's check the length of data. So length of data, and this would be employee ID. So over here I'm having 30 different employees, right? 30 I think would be too large, maybe 125. So now if I check length of data, then employee ID, so I'm having 25 employee details, right? So this is the employee ID. Then I need to mention the name, so I'll be writing the Indian names, let's say Ankit. All right, so currently I've mentioned 1 2 3 4 5 6 7 8 9 10 names, right? So maybe moving forward I can write couple of other names. And then maybe I can pass. Okay, Karan is done, right? So maybe the how many names are we done with? 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21. 21 names we are done with, right? Then maybe I'm passing let's say Nitin. Then let's pass Ritvik. Then I'm passing Tanmay. All right, and then maybe Anil. So let me check the length. what is the length of data name. So yes, even we do have 25 names, right? So these are the employee IDs. Then I've mentioned the different employee names. So once we have this, then I have to mention the age. Age could vary. So instead of let's say choosing some writing 25 names, over here I'll be mentioning some random age list. So maybe over here I can say np.random.choice. So the choice would be from list. Range would be maybe from 21 to not 21, maybe let's assume 24 to 45. All right, and how many values do I need? So I can mention the size as 25. So this would generate, let's say, 25 random age values between the range 24 to 45. Then I have to mention the salary as well. So next I'll be writing salary, again np dot random dot choice. All right, and then I can mention list, range, and the salary, let's say, would vary between 30,000 to maybe 80,000. All right, and how many let's say, what would be the size? The size would be 25. So means currently it won't be dependent on the age because I'm using some random values, right? So let me check the length of data employee ID. Only if the four lengths are same, then I can proceed with the data frame creation. Next I've passed name, then I'm passing age, and next I'm passing the salary. So guys, clearly we can see that all the four lengths are same. So means once this dictionary is created, then I can move on to creation of data frame. So let me check the type. What is the type of data? The type of data that we have over here is dictionary. Now, why have we chosen this data? Okay, besides this, let's understand. For instance, suppose if I were to, let's say, determine to create some kind of machine learning model where maybe based on age, salary, and experience, I want to determine whether the employee should be promoted or not. Now, if we use some, let's say, distance based algorithm, so because the salary would have a much higher range and age would have a much lower range, and likewise experience would have a much lower range, that would be a hindrance. That would be a hindrance. All right. So means salary values would majorly be used to determine whether the employees would get promoted or not. So essentially this problem can be resolved using the scaling, where we can scale multiple columns having different ranges into the same size or same scale. For instance, the earning age would vary from 20 to 45, but the salary ranges from 30 to 80, right? This is where we have a major, let's say, range. So we can set this, we can set the same scale. We can set the data into same scale using the concept of standardization and normalization. So experience, again, it would be np.random.choice. Experience is either going to be 1, 2, 3. All right, these are the three options that I'm passing, and the size is going to be 25, maybe 4. That's it. So after experience, then I'm passing city. So even for city, I'll be using np.random.choice, and the different cities that I'll be passing are Delhi, Noida, then maybe Pune, Kolkata, and Mumbai. All right, and how many values do I need to pass? The size that I'm setting over here is 25. Over here I'm setting the size as 25. These are the 5 cities, right? So let's create this data frame. So even if I check these two, after let's say employee ID, name, age, salary, we'll have to check experience, and next I'll be checking length of data city. So hoping all the length are means all these lengths are 25. So once these lengths are 25, then maybe I can create a data frame out of this dictionary. So let's see how to create this data frame. So for data frame creation, what can be done? Over here I'm writing df, or let's call this df1. df1 is pd.dataframe, and in this data frame I can pass the data1. All right, and then I'm writing df1. So this is data, right? Not data1. So now we have obtained employee ID, name, age, salary, experience, and city. Now clearly age, salary, and experience, they are not in the same range. What do we mean by same range? The difference between the minimum and the maximum value is referred to as range. So if I were to compute the range between age, experience and salary, it would vary quite a lot. Let's check this. And then we'll understand the concept of standardization. So over here we do have a function called describe. In data frame we have a function called describe that returns the statistical information. So excluding the employee ID, the minimum age that we have is 24, the maximum is 44. So what is the gap? 44 minus 24. This is the range. The minimum salary is 30,294, maximum salary is 78,040. Now over here the gap is not a 2-digit number. The gap is a 5-digit number, right? Likewise, the experience over here is 1, the experience over here is 4. So the gap is only 3, which is a single digit number. So clearly age, salary and experience are not in the same scale. This is where we need to bring the data in the same scale or same range. So maybe if needed, we can compute the range. So how can we compute the range? I just need to write, let's say the range for age. For age, it would be df age dot maximum minus df age minimum. All right, this is the range, let's say for age. Then over here I have to mention the salary. All right, and then I'll have to mention the experience. So salary, okay, this is df1. The data frame that I'm using is df1, not df. So observe the range. For age it is 20. Why? Because 44 minus 24 is 20. For salary it is 47746, as in difference between these two values, and for experience it is 3. So clearly the data is not in same range. We have single digit number, we have 5-digit number, and over here we have 2-digit number, right? So the data is clearly not in the same range. This is where the concept of scaling comes into picture, and to implement scaling there are two approaches. We call them standardization and normalization. So first we are going to discuss the concept of standardization. So guys, standardization in other words can be defined as rescaling the attributes or features in the data frame such that their mean becomes 0 and the standard deviation becomes 1. So currently if we see the mean, what is the mean age? It's 36, mean salary is 55482 and the mean experience is 2.92 years. So clearly the mean is not 0 and the standard deviation is not 1. All right, standard deviation is square root of the square root of the variance. Variance is deviation between the actual values and the mean values squared. That is the variance. So if we take the square root of the variance, that is the standard deviation, right? So after applying standardization, the mean of the data becomes 0 and the standard deviation becomes 1. So this is what we have to let's say work with. So what is the formula used? The formula used is x minus mean upon standard deviation. X is the individual values, mean is the overall mean of the column upon standard deviation of that column. All right, so we'll be using sample standard deviation. Now we can't select the range. So the output, let's say it need not be fixed in a specified range. Means of course it would be similar, the scale would be reduced. The original scale, currently the data is not in same range. After standardization the data would be in the same range, but we cannot select the range. We cannot say that it would be between 3 to 5. We cannot claim that it would be between 10 to 40. All right, this range selection is not practically possible when it comes to standardization. So this is the formula. I've mentioned the formula in detail. Zi is referred to as the scaled data or the Z score, where Xi is the data to be standardized, Xi. Nu is the mean of the column that needs to be standardized. S is the standard deviation of the column that needs to be standardized, right? This is I. And what is Zi? Zi is the resultant standardized value for the given Xi. So guys, I need to standardize these three columns. We have age, salary and experience. So let's consider this. So before moving forward, I would like to create a copy of the data frame. df2 is df.copy, df1.copy, right? So let's see this. So over here I'm selecting my x would be the data. So from the df1 I need age, then I need salary and I need experience. These are the three columns that I need. All right, these are the three columns. Now for each of these columns, I need to apply this formula: individual values minus mean upon standard deviation. All right. So instead of X, let me write this df standardized. This is the data frame standardized. All right. So in this data frame standardized, the data frame standardized, I'll be writing df1 standardized. Uh, this is these are the original values, right? These are the original values. How do I transform the age? So age would be transformed as df1 age minus df1 age dot mean. Individual values minus mean upon standard deviation, right? This was the formula. See, if you observe the formula, individual values minus mean upon standard deviation. So I'll be applying the same formula. So individual values minus age upon mean, and then this numerator would be divided by the standard deviation. So this would be over here I'll be writing what is the standard deviation. So this would be age dot standard deviation. But I have to use DDOF. DDOF is degree of freedom. So maybe DDOF would be 1. This would be 0. The same, let's say, concept I have to apply to other columns. Then DF1 standardized. Then after age, we have salary. This would be DF1 salary minus DF1 salary dot mean. All right, and this would be divided by df1 salary dot standard deviation, where degree of freedom would be 0. All right, and the same I can apply for the experience. So I'm using the same formula, right? There is no change in the formula as of now. Means there are other couple of libraries using which this can be implemented. So I do not have to implement it from scratch for each and every column. All right. So for these 3 columns, this is the standard deviation approach that I've applied. So let's check this df1 underscore std. If you observe the formula, individual value minus mean upon standard deviation. So this is the individual value minus mean upon the standard deviation. Then again, individual values minus mean upon standard deviation for salary, and individual values minus mean upon standard deviation for experience. So we can ignore the warning. All right, and let's say for ignoring the warning, maybe I can utilize this. I'll show you what can be done to ignore the warning. I can import warnings and then warnings dot filter warning, and then I can mention ignore. So now if I run this, I won't be getting any warnings. Yeah, so the warnings are gone. So observe this. Now clearly we can see the data has changed, right? The data has changed because we have applied this concept. We have applied the standardization. So what kind of transformation, let's say, have we carried about? Let's see this. Now df1 standardized dot describe. If I describe this, so now if you observe the minimum, this is the minimum, this is the maximum. Previously the minimum age was 24, the maximum was 44. Minimum salary is minus 1.55, maximum is 1.42. Minimum experience is minus 1.81, maximum is 1.023. So now clearly the data is in similar range, not exactly the same range, but definitely similar range. And this means this does not seem to be 0, but it is very much close to 0, and this value is very much close to 1. So if you don't see this 0 and 1, what can be done? We can round this off. We can round this off, right? So now if you observe this, even if I pass 5 digits after decimal, so this is still 0. Even if I pass, let's say, maybe 10 digits after decimal, so this is still 0. So the mean is 0 and the standard deviation is 1. All right. So this is the purpose of scaling. So bring data to the similar range. So originally the range was this. This was the original range. All right. Now this is range. This is the range before standardization. This is the range before standardization, and then I'll show you the range after standardization. This is range after standardization. So what all changes do I need to bring about? I just need to replace df1 with df1 std. That's it. So guys, This is 3.44, this is 2.96, 2.84. Now these values are all single digits and very much close to each other compared to the original scale. The original scale was this 20, then 47746 and even 3. So clearly the data was not in same range, but after the standardization now the data is in the same range, right? So this is the impact of standardization, and this was the formula that we have used. So guys, moving forward, let's proceed to the normalization. So let's understand the concept. So the very goal of normalization is again to bring the data to the similar range. So we are supposed to, let's say, change the values of numeric columns in the data set, and we are supposed to use a common scale. Now, contrary to standardization, over here we can set the range. We can set the range of values between which the scaled values would lie. All right. So we are scaling the values such that we don't have to distort the differences in the range of values or without losing the information. This is the core objective. So the default range of values is between 0 and 1. By default, if you apply normalization from the library, so the default range would be 0 to 1. However, we can scale it between -1 to 1. We can scale it from 50 to 70. We can scale it from maybe 25 to 28. Any range we can scale this up to. So the benefit of normalization is user can select the range. If I want to scale my values between 0 and 1, that's possible. If I want to scale my values between -5 to +7, that's also possible. So what is the formula used? So for each column, first I have to find the let's say standardized value, which is the individual values minus mean of that column upon the max minus minimum of that column. This is the first step. And the second step is the scaled value, where the standardized value is multiplied with maximum minus minimum from this range or whatever range that the user selects. So first of all, we'll see df2. This is the df2, right? Let's say, okay. So X I've utilized over here. In the df1 standardized, I've used these columns, so I'll be using the same concept. Over here, I'll be writing df1 norm is df1, and then what all columns I need to select? I need to select age, then I need to use salary, and after age and salary, I'll be writing the experience. All right, so guys, these are the three columns. So df1 norm. Over here I'm writing df1 norm. So we have age, salary and experience, and I'm displaying the head. All right, now once we have this, what is the next step? The next step is to apply the normalization based on this formula. So first, let's say we'll normalize age. Normalize age. So maybe I want to, let's say, normalize all let's say normalize the columns age, salary and experience in the range. So what range shall we use? Let's use the range maybe between 2 and 4. Over here my range is between 2 and 4, or let's say between 2 and 5. So the minimum value would be 2 and the maximum value would be 5. This is the scale that we have chosen. It could be any scale. You can change this number at any time. So let's see this. So first of all, we'll be scaling the, let's say we are going to scale age. So what can we write? The column is df1 norm, right? So this is df1 norm and then age. This would be df1 norm age minus df1 norm age dot minimum. All right, if you observe the formula, this is the first standardized value. So we have to apply the formula twice for each column. So this is the standardized value. This is the numerator, individual values minus mean. So this is individual values minus mean upon df1 norm, and then I'll be writing age dot maximum minus df1 norm age dot minimum. All right, this is what we have written. This is what we have mentioned over here. Clear? So age minus age minimum upon, let's say, max minus minimum. So this is for the age, and then df1 norm age. This would be df1 norm age. Then what is the second part of the formula? This is the scaled value into max minus min plus min. So this into max minus min. The max and min that we have chosen is 2 and 5, right? The max and min that we have chosen over here is 2 and 5. So max minus min. So 5 minus 2, all right, plus 2. So now if I check df1 norm age, if I'm just writing df1 norm, so observe this. Now the age values varies between 2 and 5. The original age was this, but now we have normalized it between the range 2 and 5. Correct? Likewise, I can apply the same concept for salary and experience. So I'll be writing df1 norm salary is df1 norm salary minus df1 norm salary dot minimum. And then over here, I have to mention df1 norm salary dot maximum minus df1 norm salary dot minimum. All right, and then df1 norm salary is equal to df1 dot norm salary into maximum minus minimum plus minimum. So into 5 minus 2 plus 2. So now the salary would also be ranging between 0 and 5, between 2 and 5. I'll show you df1 norm dot head. Please check. Now even the salary ranges between 2 and 5. I'll show you the minimum and maximum value once we have computed it for the experience as well. Now let's apply the same functionality to the experience. So this would be df1 norm experience is equal to df1 norm experience dot minimum, all right, minus minimum upon df1 norm dot maximum minus df1 norm experience dot minimum. So this is how we can apply the standardization and normalization. So let's see this max minus minimum, and then this would be df1 norm experience would be df1 norm experience into 5 minus 2 plus 2. All right, so this would be df1 norm dot head. So now we have applied the normalization on all the three columns. So if you observe this, this is my age, salary and experience. So from the df1 norm, so if I check, if I use describe, so observe what is the minimum age 2, maximum age is 5, minimum salary 2, maximum salary 5, minimum experience 2, maximum experience 5. All right, so what was the range that we chose? The range that we chose was minimum 2 to maximum 5. This is what we have scaled down the data to. So this is how the scaling works, especially in terms of normalization, right? This is how we can apply the concept of normalization. Now once we have applied the normalization, let's check the range. So now clearly the range is 3, right? So the way we have mentioned it over here, we can also mention it over here. So this is range after normalization. Now instead of standardization, I just need to change it to normalization. So guys, for age the range is 3, for salary the range is 3, and even for experience the range is 3. So guys, this is how we can implement data scaling, essentially using the concept of standardization and normalization. So guys, that brings us to the end of this session. So let's proceed to the PPT. So guys, in the next session we'll be concentrating on encoding categorical variables. Thank you.